So welcome to CS10 PE2 Compilation. Today we'll be going through question 9 in the compilation, which is 2410 question 2 on data analysis. So for all data analysis questions, the first thing you should do is download the CSV file. So download both the template and the CSV file. In this case, I've downloaded it already. This is the template file. It contains your read CSV function. Test cases for both parts of the questions in this case that you can use. And more importantly, we have the data in the CSV file. So first things first, step 0, we should always just open the CSV file, make sure that we have downloaded it correctly, and just take a look and make some sense of the data of what we're looking at. So in this case, we have a header where containing strings describing what's stored in which each of the columns, and then we have different rows. Each row here, your data entries, right? So going back to the template file, we are given this read CSV function. It takes in an input of where the CSV is. For all intents and purposes, for PE2, it will be in the same directory as your template file. It takes in the string and it outputs a nested list of lists, where each nested list is each row, and each element in the row is each of these information, each cell information, separated by commas. So for example, if we look at the first row, which is the header describing what's stored in each of this stuff, right? This header tells you which nth column will contain what information. So for example, the 0th column will have the IMO number, the first column will have the name, second column will have the ship type, so on and so forth. So port of registry, verifier country, and the annual average CO2. Yeah, I'd like to just copy it over here and just give myself a legend for me to refer to as I work on a question. Okay, so you can visualize this as a table, but open it on Excel or something. But during the exam, you won't have that available for you on Glide. Yeah. Okay, so this mental image of like a table is actually quite useful. Because if we follow nested iteration ideas, by iterating through each of these rows, right, we can, for example, access the 0th element using row 0, second element using row 2, for example, so on and so forth. Yeah. So let's start with part A, right? So this question, part A. So we are to implement a function getVerifiedShips that take in a file name, a string, ship type, also a string, and verifier country, a string, as inputs, and returns an integer of the number of matching ships in the database as an output. So first things first, we should always try to break this down into subproblems, right? So the first subproblem, we need to find a way to filter out invalid ships. So maybe I'll write it here, filter out invalid ships. And accordingly, we also need to find a way to check if a ship is invalid. So based on the question, it's by matching these two criteria, ship type and verifier country. So by matching the two criteria. Right, and we have a second subproblem here, which is to find a way to count the number of ships. So you may already have an inkling on how to approach on this, but it's always just good to decompose the problem as much as possible so you can fully understand the problem. That also helps you, catch certain edge cases that you might not have caught. So these are the two subproblems, and we can start by tackling the first subproblem, which is to filter out invalid ships. Right. So simply put, we can use a filter. Filter applies a function which takes in values. In this case, it could be either of these two criteria, and returns a boolean. If the return is true, the value remains in the output. If the return is false, the value is filtered out of the output sequence. So the simplest approach for subproblem 1 is simply define a function rule, or just a lambda anonymous function that takes in each row, right? Takes in each row and checks if the second element in the row, so ship type, is equal to the specified ship type, and checks if the verified country, so fourth element, is equal to the country input, right? So this works because ship type and country are within the function scope of get verified ships. So when we call ship type and country from here, we are accessing these parameters, which take on the value of the arguments that's passed into the function. So we have this rule lambda, and we can use this rule lambda on our filter function and solve subproblem 1, which is filter rule on res or on data. Before that, remember to always import the data. So data is equals to read CSV fname. Right. So this is the full solution for subproblem 1. Next, the problem actually asks us to return the number of ships, right? So we need to get the number of ships. The filter object doesn't isn't iterable, but you cannot directly get the number of ships from it. You can easily get the number of entries from a tuple. So a simple fix would be to typecast this into a tuple as so, and use len as we've done multiple times over the course, like this, right? Return it. This should solve the question fully by solving these two subproblems independently. Yeah, so if I uncomment this, it works. Alright, actually, since we have cosmology, you can just copy paste it in and just take a look. Submit. Yeah, passes all test cases. Okay, so for the second part, right, next. For part B, now we are to implement a function getSummary, which takes in a file name, a string, and an integer k as inputs, and returns a list of tuples of the top k matching results. Each result, a nesting tuple, contains these three elements in the following order: each unique ship type, the number of ships of that ship of the corresponding ship type, and the median annual average CO2 emission of all ships in the ship type. So this, right. And we're also given two more pieces of information here, like here and before, over here and pretty much here. To compute the median, if the number of ships of that ship type is odd, the median is the middle number sorted in ascending order of the CO2 value sorted in ascending order. If the number of ships of that ship type is even, the median is the average of the two numbers sorted in ascending and rounded to 2 decimal places. And the second key information is for top k filtering. If the k plus 1th result is tied with the kth result, we include it. So just to, yeah, so that's the two information, yes. So before attempting to solve it, it's always important to, think about functional abstraction and if we can actually reuse any of the previous questions. So unlike some other data analysis questions in the compilation, we cannot reuse part A, so we have to pretty much do everything from scratch. But no worries, we have a rough scaffold from part A that we can use already. Yeah. So yes, next let's break the question down. Okay, so breaking it down, we have 4 main subproblems, I think. So the first one is to find a way to get a list of unique ship types, right? This may not be that simple, so it's it's always good to just decompose everything first. Then once we get a big picture, we can move on from that. A second subproblem that we have to tackle is how to obtain the median CO2 emission of all ship types, of all ships of a certain ship type, right? Number 3, we need to obtain the number of ships of a certain ship type. Next, we need to sort in descending median CO2 emission. And last but not least, based on this 1 to 2, 4 comparative ranking, choose top K, right? Choose top K. So let's look at each of these. Do we have, and ask the question, do we have like an obvious way to implement it, right? So for two we can define a function to get the median based off this criteria here. For three, it's similar to part A. We can use length. Once we get iterator, we can cast it into tuple, and then we can just simply count the number of elements inside that tuple. So 2 and 3 are quite simple. For 4, we can make use of the sorted function to sort it in place or not in place, but we have a way to sort it using a key as well. And for 5, I'll touch on later. We can use our the top K sorting algorithm, choosing algorithm that we've learned before to solve the 5th subproblem. So the difficult subproblem would be the first one, right? Finding a way to get a list of the unique ship types, because once we have this unique ship types, we can just choose from data like which ship is which, right? So if you think about it a bit more, equivalently, the first subproblem is actually the same as if we collect, right, all ship CO2 emissions by ship type. What I mean by this is perhaps we can have a dictionary where each key is a ship type, and the value is a list of CO2 emissions. A list of CO2 emissions. And what we can do next is, since median needs it to be sorted, right, we can just sort this, or either in 1 or 2, right? So these are the 5 subproblems that we need to tackle. Morphing the input data into a dictionary of ship types with a list of CO2 emissions. Second one, which is obtaining the median, obtaining the number of ships, sorting in descending median CO2 emissions, and then choosing a top K and addressing ties correctly. Yeah. So these are the 5 subproblems. We can start tackling it then, right? Okay. As before, the first thing we should always do is import the data. So data equals to read CSV file name, right? And then we can tackle subproblem 1 first. Maybe a good way to tackle it is to define a helper function to help us do that, right? We can define shape data, and we can shape it as such. We're primarily interested in 2 things, right? The median CO2 emission, and also the ship type. So we need column 2, which gives us ship type, and column 5, which gives us CO2, right? With our first subproblem, we just need to make this data into a res that looks something like this. So ship type 1, for example, keys of different ship types and values, each of them being lists, right? So how do we define this function? We give this data input, which is a list of lists, as we have established before. What we can do is, we can use a for loop to go through all this list of lists using the nested iteration ideas, and then process each row accordingly and put it into an accumulator. So we have a for loop, and we have an accumulator. Maybe we can call it res empty dictionary for now, right? So we are iterating through every row, excluding the header row. So data, you slice away the first row like this, to exclude the header. And then for each row, we can access the row type, the ship type, sorry, and the CO2 level. So take note that when you use read CSV, you get in return a list of lists, and within each nested list, every single element is a string. So always, if you're dealing with numeric values, you can typecast it either to an integer or a float, depending on the question. In this case, it's a float. So you typecast it into a float. Float row 5, something like this, right? And then we can check. We can add it into the dictionary. So one thing to take note is we cannot naively just throw into the dictionary. because if we have uninitialized key value pairs, we actually get key error. The dictionary will throw a key error. So we need to guard against that. So if ship type is not already in res.key, so it's not a key value pair in the dictionary, we initialize the thing with the first value here, right? If it's not, so else, then we append it. So always recall that when you're storing a list as a value, it is stored by reference, so we can directly use append to it like this. Note that the return type of append is none, so if you miss out, if you do something like this, your code will be wrong. So we reference the list directly and we append a new CO2 value to it. And then once we're done, we return res. So what this function does is takes in a data, a list of lists where each element within the nested list is a string. We iterate through every single row and work through each ship type and CO2 value accordingly. Ship type is a string, CO2 is a numeric value, so we typecast it into float, and then we append it to a value list within this dictionary res, and then we return res. So now this will be the data that we'll be working with. Right. So subproblem 1 is done. We can just call it or not call it. Right. Maybe we can move on to the next subproblem now. So subproblem 2, and actually we can tackle both 2 and 3 together because they're quite similar. Obtaining the median and also number of ships. Let's actually do 2 first. Right. So obtaining the median, again, it's easier to debug code if it's segmented and nicely abstracted, as functions. So we can just define a getMedian function, right? GetMedian. And this getMedian works on a list of ships. So the input here, right? The input is perhaps, ships with CO2 values of maybe 6, 1, 2, because we're naively just putting it into the list from shape data, right? So the first thing we need to do is we need to sort it in ascending order, as we specify here. Median emission, it has to be in ascending order. So we can use the sorted function, right? So ships sorted would be sorted ships, as simple as that. And then after calling this, our ships sorted would look like this, which is what we need to use to obtain the median value, right? So again, to reiterate, we are given instructions here. If the number of ships of the ship type is odd, median is the middle number. If it's even, it's the average of the 2 middle numbers, right? So to give us a better visualization, it's just very useful to throw in like toy cases here. Right, so perhaps we are dealing with 0, 1, 2, 3, 4, 5, like the 0th element, first element, third, second, so on and so forth of within ship sorted. So this maybe is a case of if it is even, if there's an even number of ships within a list. Maybe we have another case where it's 0, 1, 2, 3, 4. This is odd. We note that for the first case we have 6 elements. For the second case we have 5 elements, right? So this is even and odd accordingly. And then we can add in our control flow, which selects accordingly. So maybe we can have the count of the number of ships, count being length of ships sorted, right? So to check for even or odd, it's quite simple. For even, it's if it is divisible by 2 using the percent remainder operator, and then else would just be if it's equal to 1, right? So how do we deal with these two? We select the middle 2 numbers, right, for even. How do we select the middle 2 numbers? We can use floor division. So if you floor divide 6, you get 3, and it will be this, right? So to get median would simply be ships sorted, count floor divide 2 minus 1 to select the second, like for example here, this one, plus ships sorted, count floor divide 2 to select, like for example, this 3 in this toy problem, enclose it in brackets and then divide by 2. So we can naively get the median of even number of entries here, ships here. And then for the case of odd, it is simply the middle. And in this case, if we have 5 count, right, the middle will be 2. The median would be simply be ships sorted, count, floor divide by 2. Yeah. And it's specified that the median is rounded to 2 decimal places, so our return value should be median using the round function, median 2, something like this, right? Okay, so that's subproblem 2. For subproblem 3, as we have established in part A, it's quite simple. Since we have a list, right, we can just naively use the length built-in function, the len built-in function, to do what we want to do, right? So perhaps this is also a good, point for us to perform another, to solve another subproblem. I'll maybe call it 6, which is morph into the right, data structure, right? Morph into the right data structure. So we are, after calling shape data, we have something that looks like this. So it's like a dictionary of a ship type to a list. But what we actually want at the end of execution is a list of tuples. So something like this, where it is ship type 1, count 1, median 1, so on and so forth, right? So perhaps in this stage, we can also try to morph it into the correct data structure, like this. And how do we do that? We can simply use, a for loop again. So a for loop iterating. Since we're starting off with a dictionary, we can use a for loop to iterate through. We can use a for loop to iterate through every single key value pair in it. So each ship type and list of CO2 values, right? So we start off with an accumulator, a list, and for ship type and ships in shape data, so we call the function that we've defined earlier, and we iterate through it for every single row. We can just create a new nested tuple. So the nested tuple should have ship type as the 0th element, the length of the number of ships as the first element, and get the median of the median as the second element. This would be each of the nested tuples, and then we can just append it to rest, something like this, right? And next, what can we do? We are done with subproblems 1, 2, and 3. We can tackle subproblem 4, which is sorting in descending median CO2 emissions, right? So to sort in descending CO2 emissions, we can use the sorted function again, but in this case we'll add in the sorting rule, right? So the sorting rule here is for it to be in descending median emissions, right? So since we know the median emission is the second element in each of the nested tuple, our sorting rule will be lambda of row second element, right? And then using the sorted function, it will simply be this. So res key sorting rule reverse true. So it is not like this is not this is a unique way to do it, but it's not the only way to do it. Alternatively, you can do something like this, right? So since we want it in descending order, the lambda can actually just be the negative of the second element, so something like this. So we don't need to specify reverse true. It can be sorted in a numerical order. So it will be something like this, but without the reverse true. This works as well, right? So this subproblem 4 done. So to reiterate, if we go through all 5 of them, we find a way to get the unique ship types, obtain median CO2 emission values, number of ships, and then sort in descending median CO2 emissions. So the last step here is just to choose the top K. And to choose the top K, it is quite simple. We can just filter it. But before we filter it naively, we should add in some guards, right? So there are certain cases that we need to guard for, namely, what if K is larger than the length of ships that ship types that we have? What if K is a negative number or 0, so it shouldn't return anything, right? What if it's everything else? Yeah, so defensive programming ideas, right? We need to guard against all this. So for the first case, if K is larger than length of number of of all the ship types, we simply return everything. And how can we safely return everything? We do this. So we slice everything from 0 to K. Even if the length is 0, K is 0 or whatever, it would be able to return everything properly, right? So this is for the first case. For the second case, what if K is smaller than or equals to 0? In this case, we shouldn't even return anything, so we can return an empty list, something like this. All right. For everything else, we can use filter, right? We can filter away everything that doesn't, fulfill the requirements. But what is the requirements here? So as specified here, we use standard competition ranking 1, 2, 2, 4. So that means that if the K plus 1th result is tight, i.e. same median CO2 value as the Kth result, we add it into the list, right? So we can just do exactly that. So else, we get the Kth CO2 value, which is res K minus 1, 2. We return a list or filter where we filter out everything out that doesn't match it. So in this case, in this filter, we are iterating to every single row specified here after we morphed it using subproblem 6. Every single row, if the second element, which is the median CO2 value, if it's larger than or equals to K CO2, we keep it. This will return true. We go to every single row in res, and we return it. So this is the full solution for part B. Again, we can uncomment and test the code. Perhaps there's some syntax error since it's quite long. Yeah, invalid syntax. So lambda. Yeah. No attribute items. Yeah. Ship sorted is not defined. Let's see, ship sorted. Yeah. So, well, you'll definitely make some, simple name error or syntax error mistakes, but the important thing is, when you get all these error messages, right, you need to know how to fix them. You need to be able to understand, okay, if it's name error, ship sorted is not defined, the best course of action is Control F, search for ship sorted, and then fix it by seeing if there's a typo or not. And you see that most of the errors that I made are actually just typos. And if I just copy this solution into cosmology, it works. Yeah. So thanks for tuning in.